tables. The one thing that's almost guaranteed to make a LaTeX newcomer want to flip her table. In today's episode, we're going to learn how to create basic tables, how to make filling them as easy as possible, how to make a table look gorgeous and professional, and then at the end, a few little tips to help take them to the next level. As always, there are timestamps and links in the video description, and if you get stuck, please do leave a comment down below and I'll be very happy to help. Now, Overleaf saves us time and effort as usual by generating all the basic code we need to create a table. So to get started, all we actually need to do is type \begin, squigglies, table. Just like with figures and equations, this command creates an environment for the table and all its little related bits to sit inside, so that the compiler knows they all belong together. Let's just go through each of these commands line by line. As we break them down, we'll see that actually tables aren't as bad as they first appear. The first bit that we'll notice is that there's this set of square brackets right here. This is so that we can control where the table will appear on the page, exactly the same way as we did in the video on figures. H puts the table here, meaning exactly where it appears in the code. T and B mean top and bottom, which will put the table at the top or the bottom of the next available page. P will put the table on a page by itself. And you can still use an exclamation mark to override the compiler and force it to do as it's told. So then we have \centering, which, as you've already guessed, centers the table contents. We also have the caption and label commands, where we can put our caption and a unique label. And then we get to the important bit. We have another begin and end command, and these will create a tabular environment. This is where we tabulate the data, which literally just means to put it in the format of a table. Now, the eagle-eyed among you might be looking at this squiggly bracket here and wondering, hang about, Sally, what's this bit for? And that is an excellent question. This is where we specify how many columns we want and how the data in those columns should be aligned. You've got three basic options: L for left, R for right, and C for centre. So in the default table that Overleaf created, we have two C's, which means that we'll end up with two centrally aligned columns. Simples. You might then be thinking, well, that's all well and good, but what about this weird vertical bar thingy in the middle of them? That is just how you get vertical lines or borders in your table. Now, we'll talk a little bit more about horizontal lines later, but this does lead me onto a very important detour. There's a sort of open secret in STEM when it comes to tables. Not because it's actually a secret, but just because when you've been doing something for a long time, it can seem super obvious to you that that's just the way it's done, and so people just forget to mention this. Now, the non-secret secret is that you're not supposed to use lines to separate rows and columns in your tables. In STEM, we tend to really only use horizontal lines to separate the data from the headers and to show the start and end of the table. But if you're an undergraduate student and you're not sure how you should present your tables for your lab reports and whatnot, then check with your local friendly PhD student helpers. They know what the conventions are in your area of study, so they can point you in the right direction. Whew, so all that aside, now we get to put the data in. So how do we do that? Well, for each row, you separate your data into columns using the ampersand symbol. The number of columns has to match with the number of columns you told the compiler there should be, up here in these squiggly brackets. Then, at the end of the row, you put a double \, and that tells the compiler, go to the next row. So, one of the reasons that you've probably heard horror stories about LaTeX tables is because back in ye olden times, you had to type all of your data out manually, and you'd get loads of errors because, of course, you'd forget to put an ampersand or you'd put too many, and then you'd have to waste forever just looking for them. There are plenty of workarounds now. The first one, and probably the easiest, is to use an online code generator, of which there are many. These are great if you know how you want the table to look, but you don't know how to get the code working. For small or complicated tables, they can save you a lot of time and effort, and we are all about that efficiency in STEM. For most pure data tables, all you really need is a spreadsheet. Yes, that's right, I said it. If you've already been recording your data in a spreadsheet, then why not make use of that? All you have to do is insert an empty column between each data column. Fill these empty columns with ampersands, and then fill the final column with double backslashes, and then boom, just copy and paste the whole thing into your code. If you're feeling particularly fancy and you generate your data using Python or R or something else, you can format the text output to include the ampersands and double backslashes in the right places. Then all you have to do is copy and paste that output into your LaTeX table. Even fancier still, you can use your Python or R code to generate the entire table, print it all out to a .tex file, and then you can import that file into your LaTeX document using the \include command. Now, remember how I said before that we usually put horizontal lines in the tables at the start, the end, and under the headers? You're probably wondering how to do that, right? It's super simple. Anywhere that you want a horizontal line to appear, you just type \hline on that line. It's best to use the absolute minimum number that you really need. And you can probably see from this example table, which uses the default table stretching, that the rows are quite close together. And so if you put horizontal lines between each of them, like I've done here, then you have to really squint to see the data. But we can stretch our table out using this horrible looking command here. Now what this command is doing, this renew command, is it's saying to the compiler, okay, I want to declare a new rule that you're going to apply to the whole document. Then in the first set of squigglies, we're telling it which rule we want to apply. So array stretch will let us stretch our array. And then in the second set, we're telling it how much we want to do that by. Now the default stretch is 1, so anything that's smaller than 1 in this bracket will shrink the table, and anything larger than 1 will spread the rows apart. Now finding what looks good in your document is going to take a bit of trial and error on your part, so just have a play around and see how it looks. So what about the column width? By default, the column gets automatically stretched as wide as it needs to be to contain all of the information in the cell. But if your columns have a lot of text in them, then it'll just keep sizing them wider and wider until they eventually fall off the page. So how on earth can we fix that? One way is to use landscape tables, which I'm going to talk about a bit later in the video. But you can still get the problem of oversized columns even in a landscape table if you have a lot of text in them. The best way to control the column widths is to declare them explicitly. So let's have a look at our previous example, and I'm going to put a longer piece of text in one of the boxes. So where we have CCC to say we want 3 columns all centered, let's change this third one to control the width explicitly. What we want to type is P squiggly, and then put the width either in centimeters, inches, or as a percentage of the text width. In fact, let's do that for all 3 of them, just so you can see. Admittedly, these numbers are a bit silly. In a real table, I'd experiment until it looks exactly like how I want it to. But it should be enough to give you an idea of how this works. So now let's get on to the more advanced stuff that you're more likely to need if you're writing a dissertation or thesis. Usually at the start of your document, as well as the table of contents, you'll want to have a list of tables. And if you watch the video on figures, you're going to be very unsurprised to know that to do this, all we have to do is type \list of tables, all as one word. And that's literally it. It seems a little bit cheating to call this advanced, but it is something that you need to use in more advanced or complicated documents. If you're writing your captions well, then they should be detailed enough to let the table stand by itself without anyone having to refer to the body text. And that can accidentally make your list of tables way longer than you anticipated. What we do to get around that is to add a short caption whose only purpose is to sit in the list of tables and point the reader to the page where they can find it. So, where you have the \caption command and then the squigglies, we can just sneak a little set of square brackets inside there, and that's where the short caption goes. You just need to give a very short description of what the table is. And then finally, we come to landscape tables, as promised. Now these can be a little bit fiddly, but they're not very difficult. So the first thing we need to do is to add the lscape package to the preamble. So if we go back to our main.tex, and go up to the start to the preamble, and then we'll call the package using \usePackage lscape. So now anywhere that we want to put a landscape page, all we have to do is type \begin, squigglies, landscape. And then anything that falls within the begin and end landscape brackets gets put onto a landscape page. Now, the reason why this becomes fiddly is because you have to be very careful about where you put the code for your table. This is because the begin and end landscape commands essentially create new pages wherever they appear. So any text that you have after the end landscape command won't be able to wrap around the table, so you can end up with huge amounts of empty white space. So once you've made your table, you'll probably need to play around a bit with the placement to make sure that everything looks good. So now you know how to make tables in LaTeX. In the next video, we're going to cover the second most requested pain in the arse topic, references. But in the meantime, if you have any topics that you'd really like me to cover, then just drop a comment down below and let me know. I've really enjoyed reading all of your comments so far, so all that's left for me to say is, as always, thank you so much for watching, and I look forward to seeing you in the next one.